So now let's move on to the softmax function first. For that I have to explain you some things like one hot vector. So let's suppose we have some data. Okay. Um, yeah, this is the best way to explain, I think. Um, so this is enough, I guess. So this is x0, this is x1, and this is our output y. Okay, so let's suppose it has some value here, it has some value here, and it is saying that this x belongs to class 0. Let's suppose it has some values here, it has some values here. Now it is saying that it has some value, sorry, it belongs to class 1. Similarly, it belongs to class 1, it belongs to class 0, and let's suppose it belongs to class 4. So this is the form that we have our output. Okay, but now if you now I will explain you the reason that we have to. So let's suppose we have this 1 2 3 4, then we have 1 2 3, then we have 1 and 2. So as you can see here, we have two classes, this and this. So that's why we are having two output neurons. Although for two classes you can also you can just have single neuron, but I'm not going to get into that. For keep the things easy, let me explain it like this. So for because we have two classes here, we are having two output neurons. Okay, so what I am going to do for this part, now what we have to do is, let's suppose I am giving some input here. Okay, it is going to give me two values here, it is going to give me two values here. But now if you see that in this case, let's suppose this is the example that we are taking. Okay, so in this case we only have one output, that is 0. So in this case we only have one value, but in this case we are getting two values, which is not supposed to be right, because when we are using the back propagation, it is going to create problems. So what we are going to do in this case, what we are going to do is, we are going to convert our y value, original y value, into one hot vector. Okay, so what I am going to say is, we are going to convert our y like this, y 0 and y 1. So for the first part, you can say that it belongs to class 0, so it is going to say that okay, this is 1 and this is 0. Now for the second example, it says that it belongs to class 1, so y0, oh sorry, yeah, so y0 is going to be 0, and y1, because it belongs to class 1, is going to be 1. Again, it belongs to class 1, so 0 1. Then it belongs to class 0, so this is going to be 1 and this is going to be 0. And then again it belongs to class 1, so 0 and 1. So this is what we call one hot vector. Now as you can see here, we have for every y, let's suppose this is the input, we have this output. Okay, if this is the input, we have this output, this output. So for every input we have you can say like two values as output. Okay, so we have two values as output also here. So this is why it is going to work. Now what we are going to do is, let's suppose it is making some values, it is generating some values like this. Let's suppose this part is generating values, let's say it has some values like 90, and this part is generating values as 10. But now if you will see, we cannot like compare it with this. okay, because it is in 90s and 10 and it is only 1 and 0. So what we want here is we want to convert these values into the range of 0 to 1. Okay, now for converting our values from 0 to 1 is nothing. It is easily can be done by the sigmoid function. Okay, but now if we will say that okay, we can use sigmoid for this, so why we are using softmax function? So now if let's suppose we have softmax function here, so it can be used for any number of classes. Right now we only have two classes, that is also called as binary classes. We only have binary classes, but let's suppose we have 10 classes. Then in that case we cannot use sigmoid function. For that case we have to use our softmax function. Now sigmoid function is a part of softmax function. Okay, so that's why I'm going to use softmax directly. So if you have more than two classes, still you will be able to handle that part. Okay, so now what we are going to do is we are on the basis of the probability, like okay, this is 90 and this is 10, so we are going to convert it into 0 to 1. Okay, so let's suppose this is going to be somewhat like 0.9 and this is going to be somewhat like 0.1. Now what we are going to say that okay, because we are going to get the highest number, like the biggest number. So here the biggest number is this. So what we are going to say, okay, we are going to say because this is the biggest number, it means the probability is highest here. So what we are going to do is we are going to convert it as 1 and we are going to convert it as 0. So if you will see, in this case also y0 is 1 and y1 is 0. So this is the output that we are getting. So for this part we have to use our sigmoid softmax function. Okay, so I hope that you understood what one hot vector is also. So we will do all of that very soon, so don't worry about that. But now let's make a softmax function here. So let's make def softmax. In this we are going to get a value. So this is the formula for softmax. You can use it, like you can search it on internet. So this is what I'm going to do here. So our answer is going to be EA divided by np dot sum. I think it should be like this. Yeah, EA, and excess is going to be 1, and also keep dims is also going to be 2. Okay, and then we are going to return answer. Okay, so now let's check this whether it works or not. Softmax. So let's suppose we have instead of having 500 by 2, instead of having 500 example, let's suppose we have 2 examples. Okay, so what I'm going to do here, I'm going to pass some values here. So let's say 90 and 10, and then what we are going to say 50 and 50. So as you can see here, what we are saying here that this is our first example and this is our second example. So as I said earlier, that if the output is 90-10 and if the output is 50-50, so now for that reason we are passing it here to the softmax function for the activation. Okay, now let's see what is our output. It should be EA. Yeah, so if you can see here, this is exactly 1, as you can see here, and it has a power of -35. So now you can see that this part 90 is 1 and this part is 0, and because here we have 50-50, so that's why our output was same 50-50. So you can choose any of them, it's up to you. Now let me also show you. Let's suppose we have 70 and 70 30. Let's suppose we have this. So still it says that okay, this is 70, so it is saying that it is 1. And what you can do is you can also do np dot arg max. So it is saying that okay, the class 0 is having the uh, biggest, or the class 0 is the correct output. Okay, so this is how we are going to use it. Let's just remove this part. So this is our softmax function that we have implemented here, and this will work as our output activation. Okay, now we have done these parts. Let's move on to the backward propagation. I hope that you all remember the formulas for backward propagation that we have derived in our previous videos. Now this is going to be a little bit more complex, but it is okay. If you have understood my previous videos, then it is going to be easy.